everybody, and welcome to Unit 4B. So we're going to begin with our new unit, and first lesson or first mission will be all about how to find the slope and how do we recognize the slope of a line and what the slope of the line means, and pretty much about this. So you're gonna learn a lot about slope, and we are going to use it a lot in the next few weeks, even longer. So, on the left side practice assignment, we will discuss the assignments in class. So definitely you can keep in mind that this will be a combination of some type of packet, but I will let you know if we are going to exclude some examples and what examples are going to be. So please go ahead and write down find the slope and rate of change. And before we even begin, I just want to let you know that rate of change and the slope will be two exactly the same things. It's just in some cases we call it slope, in some cases we are checking rate of change. So this will have the same meaning, it's just different terminologies to use it. Now, what the slope man says. Well, slope is pretty much if we have a line and based on the steepness of the line, so for example, the line could go this way, could go a little bit kind of this way, it could go horizontal, all the way vertical, it could go a little bit like that, but you can see the steepness. Imagine you're skiing or going with a snowboard down the hill, and this will be much steeper than this. So the slope, what we call, measures how steep the line is. What is the steepness of the line? And for that reason, we have a few different type of slopes. So first, I want you to draw slope man with me. So go ahead and draw a circle. And of course, do your best. My circle, it's not perfect, but let's say this is a face or circle. And first we'll begin with one line that goes this direction and another one that goes this direction. So the line that goes up from left to right is what we call positive slope. The line that goes down the hill from left to right is what we call negative slope. Then we have a vertical line. So this is a straight vertical line, and this vertical line, it's called undefined slope. So just put U here. This is kind of letter U for undefined. And if we have a horizontal line, this is what we call zero slope, or also we can put zeros on both checks, and this is what we call zero slope. So I did this additional drawing so you guys can follow me, but now I'm gonna just take off this and I want you to add to your picture. Again, this is what we call positive slope. This one is what we call negative slope. The one that has a vertical position and U drawing, it's called undefined. That's why it's U, because it's this U, undefined slope. And the horizontal line is always zero slope. Zero slope because there is no steepness, nothing. It's just like a floor, flat and zero slope. So now, since we are familiar with the position of the lines, let's take a look at a few examples and decide which one is what type of slope represents. So I'm going to go through those examples and I'm going to ask you just to draw those pictures and we can name the slope of the lines. So tell whether the slope of the lines is positive, zero, negative, or undefined. So if you look at this line that goes from left to right all the way up, it matches this part of the slope man. So definitely we have a positive slope here, positive slope. Okay, next picture on the right, we have straight vertical line, which already some of you probably are thinking this is what we call undefined slope. Okay, down here with the straight horizontal line on the coordinate plane, we have what it's called zero slope. And the final one that goes down the hill from left to right is what we call negative slope. So in some examples, you will have to decide what type of slope you see when you look at the line in the graph. Next example, we're going to write down how to find the slope. Please make sure you write down find the slope, and this is the general slope formula. And the general slope formula says the slope is equal to rise over run. Rise over run is how many blocks we rise and how many blocks we run to the left or right. So how do we decide what the slope is equal to? First, I'm going to write m equals here, and we will begin with the y coordinates. So the rise, or rise over run, is the change of y up or down over run change of x to the left or to the right. So we have two intersecting points here, and we're going to count first this. We have one block on the top that rises. So this is when we rise, we go up or down. For example, it depends of the point of view, but it always goes up and down. And so once we make one block to here, then in order to reach this point, we are moving another 2 blocks. So 1 here, 2 here. Rise over run. So 1 over 2 will be the slope I'm looking for. So that was the first one. Now, if you go ahead and make a little sketch like this, put x and y coordinates on your paper and put some measurements 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, and so on. Then draw a line, and the line should intersect y at 3 and x at 4. Once you have those two intersecting points, then we're going to write down the slope. So if you need to pause the video right now and take a moment to finish your graph, please do so, and then come back. I will continue my explanation. Okay, so we need to get from this point, rise down, and then run to get to the next point. So let's see how many blocks do we rise down. We have 1, 2, 3 blocks. So I'm going to put number 3 here. And I know the change of y is the top number, so 3 over, and then from here we have another change that goes to x, to the next point. So we have 1, 2, 3, 4. So this will be 4 jumps. Or the slope in this case will be 3 over 4. Now, once you're done with counting, next thing I want you to pay attention is what type of slope we have given. Because this one here was a positive and we keep it as a positive number, but this one, remember, it's going down the hill, so we have to add a negative sign, and this will be slope of negative 3 over 4. Alright, very good. So I'm gonna keep going to the next example, and you guys will follow me if you're ready. If not, take a moment, finish, and come back to the video. So next example that we are going to discuss will be, we're going to find the slope that passes through a certain points. And one way to do this is by having x and y coordinates and writing the scale of the coordinates. So for example, 1, 2, 3, 4, 5, 6, 7, 8, negative 1, negative 2, negative 3, negative 4, negative 5, 1, 2, 3, 4, and negative 1, negative 2, negative 3, negative 4, negative 5. So once you have your scale, next thing, go ahead and plot those points. So negative 3 and 3 will be negative 3 for x and negative 3 for y. This is the location of the first point. And then we have 0 and 0 second point. We do have the 2 points plot on the coordinate plane, so I'm going to connect those. And my next step will be from the graph to calculate the slope. So how do we calculate from the graph? Well, we need to go this direction and then this direction. Okay, so this is kind of a little triangle. And we know that the upper direction stays for rise. So let's see how many blocks. 1, Okay, so one, two, one block, two blocks, three blocks. So we raise three blocks on the top, and then we run another 3 over here to get to this point. So the slope will be 3 over 3. It goes up, which is positive slope. So we can leave it like that, or we can say m is positive 1 if we want to simplify, but most of the time we may leave it like this for now. Alright, so following this example, I do need you to practice with the other one. We will do exactly the same steps. First, we're gonna put some scale here and number our coordinate plan. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, negative 1, 2, 3, 4, 5, 6. And definitely when you start your practice examples, you're going to use graphing paper, so you don't have to do this, but just for the video notes, it's a little bit easy and quicker. So first point is negative 2 and 0. So we have negative 2 for x and 0 for y, which means the point is exactly here. And second point, we have 4, positive 1, 2, 3, 4 for x and negative 2 for y, which means second point is right here. So now I'm gonna go ahead and connect those 2 points. And then we want to calculate the slope. So the slope will be equal to, now first thing, the line goes down, so I'm gonna put negative sign and not forget that this is a negative slope. And second thing, we want to get from this point here all the way down here. So remember, rise is always going up and down. So how many blocks do we rise here? If you look at this, it's 1, 2 blocks rise. And then from here we have 1, 2, 3, 4, 5, 6. So total of 6 blocks. So from here we're going all the way to the first point, 6 jumps. So the slope is negative 2 over 6. Alright, awesome. So I just showed you how to recognize what the slope is, positive, negative, 0 or undefined. Then I showed you if we have a graph with points or a line that intersects points, how to count the jumps in order to get the slope. Next example was about if you have given points and you gotta plot those points and connect the dots to make a line, again, after we have the graph, what the slope is equal to. And the final thing in this video, we'll talk about how do we use slope formula to do calculations without using graph to calculate the slope. So imagine not always the graph will be provided for you, but if you have 2 points and you know the coordinates of this 2 points, by using a special formula, slope formula, we will be able to calculate that and see what the slope is equal to. So go ahead and write down the slope is equal to rise over run, and this is what it looks like, rise over run, and we already discussed that in previous example. Now from this formula we jump to this one that we can use the coordinates of the points to solve the formula of the slope without using the graph. Now the slope formula says y2 minus y1 is over x2 minus x1. So again, y2 minus y1 over x2 minus x1. And all of those y1, sorry about that. So all those y1, y2, x1, x2 are the coordinates of actual points. So if I have one point, I will call the coordinates x1 and y1. Let's say this is my first point. And if this is my second point on the graph, the coordinates will be x2, y2. So using the coordinates of the points, if I substitute them into the formula slope formula, I will be able to calculate the slope. So let's begin with actual example. If I have given in this example that I have 2 points with coordinates of 0 and 6, and let's measure or label those as a x1, y1. So those are x and y coordinates. First point, x1, y1. Second point will have coordinates of x2, y2. After you label your points, now you can go ahead and apply the formula. So I'm going to write down m is equal to y2 minus y1 over x2 minus x1. So we always begin with the formula, the actual formula, and now we're going to go ahead and substitute each one of those variables with the numbers given from the problem. So y2 is negative 4 minus y1 is 6. This is over x2 now is number 5 minus, now notice that the formula has a negative sign, so we are using those negative signs, minus, and x1 is 0. This will be equal to negative 4 minus 6 is negative 10 on the top, and 5 minus 0 is 5. So negative 10 over 5 or negative 2 will be my final answer here for this slope. Okay, let's do one more, and that will be the end of this video. And we can do a couple more examples together later. So if I have, again, given 2 points, I label those as x1, y1, x2, y2. Once we label the points, next step will be to apply the formula. If you think that it makes sense the first time, you can go ahead and practice on your own and check with me. If you want to follow me on this example, that's perfectly fine too. So after we label the points, step 2 will be to write down the slope formula. y2 minus y1 over x2 minus x1. Always write down the formula so you don't forget which variable goes first, second, on top, on the bottom, and will not make mistakes. So let's go ahead and substitute. Y values are always on the top, so we begin with this one, y2, and I will say 4 minus y1, look at this, minus 4, and the bottom one will be x2, which is negative 3 minus 0. We have 0 for x2. So it goes this way, y2 minus y1 over x2 minus x1. Okay, so the slope is equal to 4 minus 4 is 0 over negative 3 minus 0 is negative 3. But what do we also know? If we have 0 on the top, number on the bottom, this is always equal to 0. So we have 0 slope here. And if we have 0 on the bottom, for example, 5, let me write this down here. If I have 5 over 0, this is not possible. We cannot have 0 as a denominator, so this will be what it's called undefined slope. But as I said earlier, we will discuss some of those in class, and we will talk about all of those types. I do have a couple more examples here. If you want to do them, I would stop the video now. Definitely we will have enough practice examples, so if you want to also finish your work here, that will be great. And thank you for watching the video. We'll talk about the slope more in class. Bye.